Here's an example of a question that came up in my research. Take a matrix with a square matrix with x's down the diagonal and with 1's everywhere else. Is there a nice formula for the determinant of this matrix? And don't worry if you don't know what determinant is. All that matters is that I can type in det in Mathematica, and that will compute the determinant of a matrix. And this is an example of something where trying small cases like a 2x2 matrix or a 3x3 matrix, I wasn't able to see what the pattern was on my own, and so I used Mathematica to help me see the pattern. So what we're going to do is we're going to first make a matrix, an n by n matrix of all 1's. Then I'm going to use something called a do loop to change the diagonal entries to x's. Okay, just the variable x. And then I'm going to take the determinant of that matrix and see if I notice a pattern. So how do you make a matrix in Mathematica? Well, let me just remind you. Say I do m equals 1, 2, 3, 4. Okay, divided in curly braces like this. And then say I look at it with this matrix form command. So what's the syntax for making a matrix? It's a list of lists, and each inside list is one of the rows of the matrix. So first thing I want to do is make an n by n matrix of all 1's, and then I'm going to change those diagonal entries to x's. So let me start over a little bit with this. I delete those things. It's going to be an n by n matrix. Let me start out with n equals 7. And I'm going to do this in the same cell, so I didn't do shift return, I just did return. And the reason for that is later on I'm going to want to change what n is, and I don't want to have to go and reevaluate all the subsequent lines. So by having them all in the same cell, that means I'll just have to hit shift enter once to evaluate all of them. So first let's make a row. In something like MATLAB, I would never call it the name row, but in Mathematica, since I'm using a lowercase letter, I know that's fine. I don't have to worry about it overlapping with something already defined in Mathematica. So I want this to be a list of length n of all 1's. Okay, that's what I'm starting out with. So really easy to make that. Use table, and then I'm going to say make n of them. Okay, so let me evaluate this so you can see what it looks like. So here's an example of row. And now let's make a matrix. So I'm calling it matrix with a lowercase m. And this is supposed to be a list of the rows. So it's really just as easy as what I just did. It's just instead of putting 1 as each of my entries, I have a whole row as each of my entries. So let's look at it. So this is a length 7 list of lists, and each entry in the list of lists is one of these rows. So it's like saying, give me n rows, put them in a list. Now for something that's very new for us, I want to change the 1, 1 entry. I want to change the 2, 2 entry, and so on. So just as an example, say I do matrix. Let's go, how about to the 2, 5 entry? So this first 2, that gets me to here. And this 5, that gets me to here, to the 5th entry in the second list, the second inside list. And let me just make this equal to, how about 73? And then let's look at this matrix. So what did I do? I changed the 2, 5 entry, the entry in row 2, column 5. I changed that to 73. So I want to do the same sort of thing, except instead I want to change the 1, 1, the 2, 2, all the way down to the n, n entry. I want to change all of those to x's. And I'm going to do that using something called a do loop. So how does the do loop work? Well, it works really similarly to table, works really similarly to sum. It's going to have the form before the comma is what I want to do. After the comma is going to be what are the values. It's going to be some iterator. So this I'm going to say I from 1 up to n. So for our n, it'll be I from 1 up to 7. And then what do I want to do? Well, this is the easier part. I want to go to the ith row, the ith column, and set that equal to this variable x. So what is it? I'm telling it what to do, and then this iterator is saying what values do I do it for. So for I equals 1, for I equals 2, all the way up to for I equals n. Now I'm going to evaluate all 5 of these lines at once, since they're all in the same cell. And there we go. That's perfect. That's what I wanted. Now let me have a line where I compute the determinant. So it's going to be really hard to see any pattern with this determinant. Okay, I see lots of things are divisible by 7, but other than that, I don't really see anything. But watch this. I can do factor this polynomial. And so n is 7, and then I get this pattern for the determinant. It's x minus 1 to the 6th power times x plus 6. So let's try changing that 7. Let's try changing it, how about to a 4, and evaluate. Oh, looks like a really similar pattern. I get x minus 1 to the n minus 1 power times x plus 3. 3 is n minus 1. Okay, let's try another one. Let's try 13. Yep, 13 minus 1 is 12, and here is x minus 1 to the 12th times x plus 12. So unfortunately, in math, you can't use this kind of empirical evidence to prove anything, but that gave me a really good idea of what I was trying to prove in this research project, and then I used properties of the determinant and induction to actually prove it. But Mathematica is what I use to decide what is it that I should be proving, like what's the base case and what's the inductive claim.